What's up guys, how's it going? So today we're gonna solve the linked list cycle problem from leetcode. So you're given a head of a linked list and you need to detect if there is a cycle in the linked list or not. So let's understand the problem more. So in linked list, we know that there is a next pointer. So 1 is pointing to 2, 2 is pointing to 3, and 3 is pointing to 4. That's a normal linked list. But if one node has a link to one of the previous nodes, like you can see from here, then you have a cycle. So if you try to iterate over all the nodes in the linked list, first you will go from 1 to 2, then 2 to 3, then 3 to 4. And since 4 has a link with node 2, you will again go to node 2. And from node 2, you will again go to node 3 to 4, 4 to again 2, and this loop just never ends. If we didn't have a cycle, then node 4 will actually point it to null. So how can we solve this problem? Well, the easiest solution would be using a hash map. So we can start looping over all the elements, but during the iteration, we will also keep track of a hash table. So on each iteration, if the node that we are currently on doesn't exist on our hash map, then we can add that node to our hash map. And then we can go to the next node and do the same thing. If the node doesn't exist on hash map, we will store that in the hash map. If the node exists on our hash map, that means that we have already seen the node. This linked list has a cycle. Let's go with the example. So I will start with node 1. Node 1 doesn't exist on our cache. So I will add node 1. Then node 2. Node 2 doesn't exist on a hash table. So I will also add 2. Then node 3. Node 3 also doesn't exist. So I will add node 3. Node 4 also doesn't exist. So I will add 4. And 4 will actually now point to node 2. And we have already seen the node 2, which means that the linked list has a cycle. The time complexity of this will be O of n because we have to loop over all the elements. And the space complexity will be O of n, where we will also store all the node references. That's a completely valid and good solution. But the problem is that you are also asked if you can solve this with a constant memory, with a constant space complexity. Well, this is where it gets a bit tricky. How can you even know that if you have seen the node before without storing somewhere? This is where we have this Floyd cycle finding algorithm. You can learn more about the algorithm from this website. So basically, you will have two pointers, fast and slow. So I have this red arrow, which is actually the slow pointer, and the green arrow, which is actually the the fast pointer. So like before, we will iterate over the linked list. Our fast pointer and slow pointer will move differently. The slow pointer will move one node after another. But on the other hand, the fast pointer will move by two nodes. So from node 2, it will skip the node 3, it will go to directly node 4. But how this algorithm solves our problem? So if we start iterate over the linked list, our slow pointer will move slowly and the fast pointer will move faster. And if the linked list has a cycle, at one point, both of this arrow or the pointers will actually point to the same node. And if they point to the same node, this means that the linked list has a cycle. If the linked list doesn't have a cycle, our fast pointer will hit null. So let's go over the entire linked list. So our slow pointer will point to the first node and the fast pointer will point to the second node. So on iteration, we can check, do the nodes matches? Well, in this case, it doesn't matches. So we will move on. So the slow pointer will move by 1 step and the fast pointer will move by 2 steps, point to 4. Now, do they match? No, they don't match. So now the slow pointer will point to node 3 and the fast pointer will move by 2 steps. So it will go to 2 and then it will go to 3. And now you can see that both of these pointers have actually pointed to the same node. So this means that our linked list has a cycle. But what if our linked list didn't have a cycle? If I remove the cycle, what would have happened? So let's start from the first and second node. So on each iteration, the second node will move by 2 steps. So 1 step, 2 step, and node 4 will actually point to null. So there is no other node to visit. This means that our linked list doesn't have any kind of cycle. So you might think this is a bit complicated, but it's actually not. It's pretty easy to code it up. So let's just do that. So first we need to check if the head node is null or not, and also if the second node exists or not. If they don't exist, if there is one node or if there is 0 node, we can just return false. So if head doesn't exist or head.next doesn't exist, we can just return false. Otherwise, we can create our pointers, fast and slow. So fast will point to head.next and slow will point to head. And now we can do a while loop, and we want to do the loop until fast and slow pointer point to the same node. So fast is not equals to slow. So it could be the case that our fast pointer will hit the last node, or it will hit directly to the null node. Suppose the fast pointer was here, and if it moves by 2 steps, then it will directly point to null. So we also need to handle that case. So the condition should be if fast doesn't exist or fast.next doesn't exist, we can just return false. Otherwise, we can reassign our pointers. So slow will now be slow.next, and fast will be fast.next. And if the fast pointer ever hits null, then it will directly return false. Otherwise, we will keep looping over the linked list until the fast and slow pointer points to the same node. So after that, we can finally just return true. So if the loop successfully runs and stops, then we can just return true. We can assume that the linked list has a cycle. So that should be it. Let's run the code. And let's also submit. And it has accepted our solution. So that's it for today. If the video has been helpful for you, don't forget to like, share, and subscribe to my channel. And I'll see you in the next one. Goodbye.